Hello guys and welcome back to Leet Logics. This is the power of 4 and it is a Leetcode easy. The number for this is 342. But I guarantee you that I will make this problem for you much more easier than it is. It is already easy but I will make you more easy for you. So let's start with the question. In this question you are given with an integer n and you have to return true if the integer n is in the power of 4. Otherwise we have to return false. So what is the power of 4? If n can be represented in the form of 4 to the power of x. So basically there are multiple approaches to solving this question, including first one including a brute force recursive, the second one is using the library functions log, and the third one is using bit manipulation. I am going to tell you all the three approaches. Please watch the video till this end because uh, it is important to know all the three approaches in an interview. So let's start with an brute force approach. So the brute force approach will be like you can check if uh, it is divisible by 4, then you divide it multiple times, otherwise you return false. So it will be something like this. So let's take example as 16. So first of all we need to write some edge cases. So the edge cases are like if n equal to 0, then we need to return false because 0 is not a multiple of 4, power of 4, and if n equal to 1, then we need to return true because 1 is a power of 4, and you know how any number raised to the power of 0 is actually 1. So if n is 1, we'll always return 1. Otherwise we'll check if n mod 4 equal to 0 not equal to 0, then we'll simply return false. Because if at any point you get a number which is not divisible by 4, like for example n equal to 5, it is not divisible by 4, then it can never be a multiple of 4. Otherwise you simply reduce the number by 4 and call recursively is power of 4, and you call n by 4 because suppose if you have taken the example as 16, then here you have checked that 16 mod 4 is not equal to 0, that is true, so it will not be returned false. So we will call for n by 4, that is 4. Then again it will come 4 mod 4 not equal to 0, return false. Okay, then n by 4 it will return 1. So from here it will be returned true. Then it will go to the n by n equal to 4 recursion call. Then it will return true to the n equal to 16 recursion call. So let's run this. I think there is some problem in this. I'll simply copy. You can see it runs fine. If I try to submit it, I hope it gets submitted. So this thing runs fine. Now this is a brute force approach. The other approach which you can follow is using mathematical functions, that is log. So here also you need to write the same edge cases. If n equal to 0, then we need to return false. Otherwise what we can do, we can return mat dot log of number by math dot log of 4. So we are using actually mathematics to solve this question. So if you represent any number in the form of log a upon log b, then it can be represented in the form of a to the power b, as you know in mathematics. So you can use that theorem to solve this question. Now we simply need to check if this is equal to 0. I think one bracket will be missing. No, this is fine. So this is a Java one-liner. You can write it in multiple languages. So this is a one-liner. This is the most elegant approach to which would seem, but the interviewer might ask that you cannot use the mat.log function because these are inbuilt functions. So in this case, you need to find some pattern, and the pattern is, come here, we'll solve the question using bit manipulation. So you can see, like if I take 16, so the number of 1 in 16 is actually 1, and the position is 4, and it is a power of 2, and the position of the least significant bit is actually even. So we need to check two conditions here. Like you can see in 5 there are the number of ones are actually 2, so this can never be a power of 4, because if a number is to be a power of 4, the number of ones in that should be always 1, the first condition, and the least significant bit position should be even always. These are the two conditions for a number to be a power of 4. So let's come to the code. So again, we'll start with the edge conditions. If n equal to 0, return false, or here we can write if n is less than or equal to 0, otherwise n equal to 1, return true. Otherwise we can take a help of the function to calculate the least significant bit, LSB, and it should be even, so we check if mod 2 equal to 0. And not only this, we need to check some more conditions like the position. Actually here we are checking the position, this function, and we need to check if there is only one in the binary representation. So for this we can use something like n and n minus 1. So this is a bit manipulation technique used to find the number of ones in the binary format. So what it does is that it will not give you 1, if it will not give you 0 until uh, the number of ones in the actual number becomes 0. So if you have an idea about bit manipulation, this is used to count the number of ones in the binary format. So n and n minus 1 will check if there will be only one, so this will become 1 in the first iteration itself. So we'll check if it becomes 0. Now we try to run this code. Says that LSB is not defined because I have not defined the function. So let's define the function quickly. So in this function, what we do is that uh, we shift the number right. That is, we perform a right shift of one digit on the binary format, and we count and we do the AND of the number with 1. So it will count the number of, as soon as it will encounter a 1 at the first position, it will return the p minus 1, and here p we have initialized as 1. So if we have a condition like we are calling a least significant bit for 1. So if we are calling for 1, so it will go inside, it will check 1, and 1 is actually 1, so it will return p minus 1, that is 1 minus 1, it will return 0. That means we are at the 0th position. Otherwise, if we call here for something like 16, so first of all, p equal to 1, it will go inside the loop. N and 1 greater than 0, no. So p plus plus p becomes 2, right shift, n becomes 4. Next times n is still greater than 0, n and 1 greater than 0, no. This becomes, p becomes 2, n is shifted, n becomes 2. Then next iteration, similarly, n becomes 1, and when the n becomes 1, 1 and 1 will be greater than 0, and in that case p will be here actually 5 till by that time. So we'll return p minus 2, p minus 1, that is 4. So that this will be returned as even. So this will be even. Here we check if it is even, and there it is returned as true. So this was a bit manipulation technique. Let's see if it runs. So this runs fine. Also beats 100% of users with time and 100% almost with space. It is because of the time and the space complexity used in this approach. You know what the time complexity and the space complexity is? The time complexity for this solution is actually O of 1. Yes, we are using constant time, because you see, we are only, for every number we are only doing this operation once, and this will this at the maximum. If all the numbers are 0, then also it will not take much time, it will return in constant time. So that's why the time complexity for this is constant, and the space complexity is obviously constant, because we are using no array, no uh, other variables. We are simply using an if else. So this is our simplest approach, fastest approach, and if you tell this in an interview, your interviewer definitely will be impressed by you. So if you like the video, please do like it, share it with your friend, and subscribe to the channel. And thank you for watching the video. Have a nice day.